esteemed guest speaker for today's FDP on machine learning and deep learning, Dr. Nidhi, Assistant Professor VNIT Nagpur. She is a renowned expert in the field. She brings a wealth of knowledge and expertise that will enrich our knowledge and insights during the session. Now I request Professor Ashish Mohan, Deputy CEO, to present to welcome Dr. Nidhi and present memento to her. Now, ma'am, you can start.
Okay. हाँ, 1 सेकेंड मुझे जुपिटर नोटबुक भी चाहिए होगा. It is running or not? Window is running ना? Jupyter notebook just type over there Jupyter JUPT. No, it is not installed. No. Then Anaconda install नहीं है.
एनाकोंडा आपको कंप्यूटर में मिल जाएगा.
हाँ तो वो भी चाहिए. जुपिटर नोटबुक चाहिए एक्चुअली मुझे.
एक ही इसमें करना पड़ेगा. लैपटॉप में है कि जुपिटर?
है क्या?
यहाँ पर है सारे पिक्चर मैंने थोड़ा चेक. हाँ है ना, सभी में है.
इस लैब में है.
हाँ लेकिन कनेक्ट करना पड़ेगा. लेकिन इसमें है ना, मैडम के लैपटॉप में है. मैडम के लैपटॉप में है. लैपटॉप में नहीं है ना, मैडम ने दो ही सुपर. आपके लैपटॉप में है तो आपके लैपटॉप
मैं लैपटॉप नहीं लाई हूँ. हाँ जी ये है ना.
चेक कर लीजिए एक बार.
अच्छा
जुपिटर है तो फिर मैं
तो क्या करना है?
वॉइस इन है.
तो पकड़ना पड़ेगा मुझे इसे. हम्म.
अगर आवाज सफिशिएंट है सबके लिए तो
Is my voice is audible? इसमें सारे पैकेजेस इंस्टॉल हैं. मैटप्लॉटलिब पे राइट.
एक बार चेक कर.
Jupyter notebook you can search over there. Yeah, it's okay, but search over Jupyter notebook. It is already along with Jupyter. Sorry, Anaconda. हाँ, yeah, this one. It is window right, and my pen drive contents you can copy over there in the desktop. Okay. Content. Pen drive कहाँ गई मेरी? In the desktop you can. Which one? PJCE. This one. Copy. Okay. Let's run the PPT under PJCE. Last one now. Connect with the projector. ठीक है. So good afternoon, all of you. My name is Dr. Nidhi Lal. I am an assistant professor in VNIT Nagpur in the Department of Computer Science and Engineering. Formerly, I was assistant professor in Triple IT Nagpur, and I have experiences about 3.5 years in that organization. And before that, I was a visiting assistant professor in Thapa University. I completed my PhD from NIT Allahabad. My MTech is from Triple IT Allahabad in the area of wireless communication and computing. Nowadays, my research domain is AI, and I am working in a problems of computer networks. So basically, I am implementing the deep learning models over the networking problems. In the networking, I have very much experience in information centric networking, ad hoc networking, cloud computing, as well as what is software defined networks. So in the today's topic, we will study about the SVM and naive Bayes. SVM is support vector machine and naive Bayes is probabilistic model under the machine learning. So before going to the more details SVM and naive Bayes, we have to first understand about the machine learning. As the previous introduction made by some professors, they already depict you that the machine learning is nothing but computer learns by its features and experiences and the data set you have provided to it, right? And based on the task of the machine learning, we are divide the machine learning into two models, supervised model and unsupervised model. There is also one model that is called semi-supervised, which is done under the reinforcement learning. But I will not talk about it. I will talk about it only the supervised learning model and unsupervised learning model. So in the supervised learning model, what happens? My data set is already labeled, right? And the machine basically learns from the labels, learns from the features and make you the prediction. There is some supervision exists. For example, in the real time, if you are enrolling a PhD in a particular organization, then a particular supervisor is allotted to you, who plays a role of a guide in all of your PhD program. So it is a supervised learning approach, right? Your supervisor will tell you that which coursework you have to pursue, which of the techniques you want to implement, which coding skills you to uh, need to progress in your PhD areas, right? And now in the unsupervised learning approaches, we are free to choose our area. Like me, I am assistant professor and I have no supervise and any guide upon on my top. I am free to choose any of the features, any of the area, any of the problem statement. So the basic same thing happen over the machine learning model also. Okay. So this SVM support vector machine and the naive Bayes comes under the category of supervised only. Means the data set is available and your data set is labeled. There might be some situation that your data set is not labeled. In case you have to label your data set. Okay? You have to define the features. You have to categorize the input variables and the output variables, means dependent and independent variables. First, we have to understand the modeling. Why we are doing modeling? In a more basic terms, we can understand modeling as a automatic prediction of things, right? Automatic prediction of things. Like if you are visiting a Nagpur city first time, I'm not from Nagpur, okay? When I visited the Nagpur for the first time to give the interview, I have no idea that at which point I should take a cab, what is the fare, what is the hotel charges, what is the food, right food, and what are the other things like the shopping and you can say the another real time necessities of life, shopping destinations. I don't know anything. But in a second year, in third year and fourth year, and now I visited all of the locations in the Nagpur. If anyone says that what is the fare charges if you are going to VNIT Nagpur to this college, then frequently I will say it will take 200 rupees by the Ola cab, right? So my brain is learning the things. And now after the learning, it is modeled in such a way that if anyone give me the test data, like this is one test data na, that what is the distance from VNIT to this college, this is one test data, then now I can immediate answer to your question that it is 198 rupees. Sometimes a prediction can be accurate, sometimes a prediction is not accurate, but both of the times there is one thing that is called the fastness and speed. If your answer is not accurate, then your machine learning model will train itself again, right? So that is the modeling. Depending on how long we lived in a particular place and travel to a location, we probably have a good understanding of commute times in our area. For example, we travel to work, school using a combination of metro like Nagpur metro, buses, Nagpur buses, trains, Ubers, taxis, carpools, walking, biking, etc. So my brain is able to learn the things, so many features it can train by time, and now I am very efficient to go from one place to any other place in the Nagpur. If anyone can tell me that now you have to go to Butti Bori, then I can definitely go to Butti Bori at a single town without any asking to any person. So this is how our brain works. The same sample is happening over our systems. For the first time, it will take a lot of time to learn, but once your model is fit over the training data, it will give you the prediction in a few milliseconds or sometimes a nanosecond. Now, model based inference. Okay. We can use models to conclude inference also. What is inference? Inference is basically the relationship between the features. The relationship between the features. In our training data, there can be multiple features. Okay, suppose if you want to predict a particular person is suffering from diabetes or not, there may be multiple factors: blood pressure, right, glucose level, heart rate, stress level, lifestyle patterns. There can be multiple features, but we have to establish the relationship between these two or these among so many features. So this relationship is nothing but the inference. Okay. Now, given a model, we can better understand relationship between an independent variable and a dependent variable. I assume that you know about the independent and dependent variables. For simplicity, I am finishing just a one line of a statement. Your machine learning model is predicting a variable that is called the dependent variable, and by the help of which variables it is predicting, it is called the independent variable, right? An example of where inference from a mental model would be valuable is determining what times of the day we work best or get tired. So there is a relationship of our working ability as well as the day of the life. Suppose in the morning we have really fresh, right, full of energy. At the afternoon somehow average, but at the night after the work job full of tiredness. So there is a relationship between that features. What is the feature? Morning, and our mood or our energy levels. What is the energy levels? That is nothing but your predicted variable. That at that particular time, what will be your mood or what will be your energy levels. So there is a relationship. Now the prediction. Prediction somehow integrate with the inference, but inference is a theoretical way. Inference is a theoretical way. We can estimate the relationship in our mind that okay, somehow if a person is suffering from the high blood pressure, there might be a chance that he and she can suffer from the high glucose level, right? But it is uncertain that the person is having high blood pressure and high glucose level is suffering from diabetes. No. Sometimes due to stress levels as well as due to some sweet intake, both of these factors can high up the positions. But there is a no diabetes threshold touching over there. Second point, blood pressure is low, glucose level is also low, but again my sugar, insulin level is high because insulin is made by your stomach process. right? So inference is a theoretical way, prediction is a mathematical model. Predictions can be valuable even they are not exactly right. Obviously, you can train again your model. Good predictions are extremely valuable for a wide variety of purposes. For example, accurate prediction, how long it will take to get from point A to point B. How long? Suppose I am saying that how much amount you will take if you are going from this college to another location, that is GMC. Somebody can take that if there is a traffic happens, then it will take 30 minutes. Somebody can take that if you have your own vehicle, then you will take only 10 minutes. It depends upon the car and bike also. If you have a bike, then maybe you can take only 5 minutes, right? So different predictions can occur, and somehow these predictions can be wrong. If you have a car and I am taking, my model is getting me the answer that you can take 15 minutes to reach the GMC, but in the actual way you are taking 20 minutes due to traffic conditions or some other things. So what is the difference between the model prediction and the inference? And as I already told you, inference is the relationship between the features and the prediction is the things made by your computational model. So inference is somehow useful to predict the things. Okay? But prediction is not possible without making any inference. You have to make some logic, because machine learning is nothing but the mathematical model only. Now let's come to the topic. Introduction is over now. Support vector machine. So support vector machine is a binary linear classification model. Linear classification. What is the linear classification? Yes. Continuous data. Why it is binary? कुछ प्रॉब्लम हो गया इससे. So in the machine learning, we have two types of problems. The first one is called regression modeling and the second one is called the classification problem, right? Regression is when we are going to predict the things in a continuous data. But classification is when your data is classified by using the labeled 0 or 1 or something cat and dog. Means the classes you can divide. Whose decision boundary is explicitly constructed to minimize generalization error. So generalization error is nothing but depends upon the matrices. Some of the matrices you will get important from the sklearn. This matrices is used to tell that how much efficient your data in order to predict the things. And at the end you have to basically minimize the error. Means if the accuracy is high, then it is good. If the accuracy is low, then you have to minimize the error. It is a very powerful and versatile machine learning model. Why the versatile? Because it can predict the things in the various real time applications. Okay? In the demo part, we will see that we will apply this SVM model into different real time applications. So it is very versatile model. Performing linear or non-linear classification. Now again, the classification problems is categorization into two parts, linear and non-linear. So the basic definition I will tell with the help of diagram also, but for the just introduction, linear is when your data set is separatable by a linear line. So that is called the linear classification. Vice versa, when your data set means data points is not able to classify into by using of one linear line. So that is called the non-linear. Regression and even outlier detection. So there is a two type of support vector machine, SVR and SVC. SVR means support vector regressor model is used to solve the regression problems, and SVC is support vector classification problems used to solve the classify the things. But in our today's session we will only talk about the classification problems, not the regression one. Outlier detection. For the outlier, actually in the SVM we have to make some hyperlines in order to categorize our data. So these hyperlines are used to measure the outliers data points which are over the boundary. Okay, that we will see again. So SVM is well suited for classification of complex but a small or medium sized data set. There is a restriction over there. If your data set is large, then I suggest you that do not apply the SVM. Okay, it will give you the inaccurate result. Another reason is why you are not applying the larger data set over the SVM, because if your data set is larger, your data points is getting higher. By using the non-linear lines as well as the linear lines, sometimes it's not possible to classify the data. Okay, if you have multiple data points, by only using one line, you are not able to classify the data into two parts. That's why. Now with the help of beautiful diagram, first we will see the definition. Support vector machine is a machine learning algorithm based on supervised learning, means your data set is labeled definitely, that can be used for both regression and classification problems. Now in this example, this is the data points. We have a data set in which there are two shapes. The first shape is a star and the second shape is circle. Okay, this one is represented by yellow color, this one is represented by red color for better clarity. Now my data points is contain two type of things, circle and star, and it is a labeled data set, means your machine learning model is a supervised learning model. Now we have to split our data points into training and testing. Once the training and testing data points are established, we have to train our SVC model. There is a model training. Okay? So we have to do the model selection also. After selecting the model, we have to train that model according to my data set. Once your model is getting trained, we have to ask to our model that this is my test data, this is my test data, now tell me which one is the star and which one is the circle. Now your model is able to classify that your red one is the circle and your this shape, that is yellow one, is the star. Okay, so this is the classification problem. Now same this data set, I am plotted this data set into the two dimension space, x and y. So in the two dimension space, here you can see it is a segregated over there, and again these data points are segregated over there. It is a common example. In the real world this thing is not happen. We will see in the demo part. But for the understanding, I am saying that it is already segregated. In order to do the segregation, the model is used to stretch a line, this line, a boundary, that is called the hyperplane, decision boundary and the hyperplane, such that we can segregate our data into two parts, class 1 and class 2. Now again we are plotting another lines, line number 1 dashed lines and this one lines. So why we are plotting that line? The reason is this one line is the marginal line for our first class data set. Marginal line. Okay, marginal line is used to stretch over there by choosing the nearest data point which is opponent to the class. You can see this one is the nearest one, so it is touching the line over there. The same way we are stretching another line also, which is close to this one and opponent to another class. Also this distance should be same. These two distance should be same. These two distances are known as marginal distances. So now in the SVM we have few things. The first one is we have to draw the hyperplane. Second, marginal lines. And third one is marginal distance. Okay. So now my data points is represented in a two dimension. These points which are nearest to my marginal lines is known as support vector. ठीक है, that's why there is a term, it is used to indicate the outliers also. In this case, these are the outliers. Now the question is, it might be possible, in order to segregate the data, there can be multiple hyperplanes possible. Yes or no? H1, H3 and H2. But which one I have to choose? That is the open question. In order to choose a perfect hyperplane, I am just converting my model into this thing. Here is a two-dimension plane which having a segregation of data points by using the vertical marginal lines and the hyperplane. Right? In the second one, same thing I am doing, segregation of the data points, but my marginal lines and the hyperlines are in different directions. Among of two, which thing I have to choose, which hyperplane I have to choose? So first we have to calculate the marginal distance. So marginal distance is d1 over there total, and here it is d2. Now we have to check that which marginal distance is higher. We have to select those plane which having a higher marginal distance. Okay? The reason is, if you are choosing the higher marginal distance, then your accuracy score will get higher. Okay? If you are nearby shuffling your data or something you are incorporating, then it may be a chance that your model is not going to predict a good results if you are choosing the D1. So in order to make the security, you have to choose the D2 distance hyperplane. So this is how we select the hyperplanes. So hyperplanes in 2D and 3D feature space. In this example, I am just stretching the segregated line, this hyperplane, by using the 2D space x and y. Okay, I am converting this one into the 3D space. So this is a 3D hyperline. Why? It might be possible that you have more than two features in your data set, right? So if you have more than two data set, means multiple dimensions you will need in order to segregate that. In that case, you will need some n spaces. In this case, it is 3. So first data point, second data point, and somehow third data point can lie above. If there is a fourth feature, then fourth data point will lie below. Now, types of SVM. First one is linear SVM and the second one is non-linear SVM. In the linear SVM is used when the data set can be classified into two classes by using a single straight line. But it might possible that applying the scatter chart, your data set will look like. Scatter chart हम बनाते हैं, उसमें sometimes your data distribution will be like this one. So in this case, this type of stretching hyperlines is not possible, and this type of problem is known as non-linear SVM. So there must be one solution exist in order to classify the data under this type of non-linear SVM model. So the solution is kernel functions. Okay. So kernel functions basically takes low dimension input space. This is a low dimension because only two dimension space only. Takes low dimension input space and converting into the high dimension input space, like you can see over there, 2 dimension and here 3 dimensions x, y, z, and segregation of the data is done by using this hyperline. So in the demo session we will see both of these two problems, linear and non-linear. So in the linear there is a kernel that is called linear only, and for the non-linear the kernel name is RBF, that is radial distribution function. Now you can see these are the support vectors, because these are the hyperlines, these are the nearest point. So these are the outliers as well as the support vectors. Now the advantages of support vector machine. The first advantage, effective in high dimension space. Okay? Dimensionality reduction and dimensionality increasing. The most common application of this high dimension space is when you are applying the human computer interaction applications. Like if you are going to see this hand in a 3-dimensional space, then you have to increase the dimensions. Okay? Now there are two terms. You can visualize this hand by using the SVM model and take the features and calculate the things that at which direction it can move. Classify the model. Right or left? Left or right? Okay? Another thing is just apply the SVM over the deep learning, integration transfer learning. Still effective in cases when number of dimensions is greater than the number of samples. Now use a subset of training points in a decision function called a support vectors, and also it is also very memory efficient. Versatile, different kernel functions. According to your problem statement, you can choose your kernel functions. If it is a linear, then it is okay. Otherwise, you can go to the non-linear functions also. So basically, it works for the high dimension space as well as low dimension space. Let's start the demo. You can use your PCs.
What software do we need to
Jupyter Notebook. Here Windows or Linux system installed? Linux.